We're going to talk about the difference quotient. So you probably have seen the difference quotient before. The difference quotient, I'll develop it for you through a graph. So suppose I had an x and y axis here, and I gave you some function which I'll call f of x, some curve, and on that function f of x, right, there's going to be specific points. So I'll call this first value that I substitute in, I'll just call it x. Well, what's the y value that goes along with it? Well, the y value will be f of x, right? So the height here would be f of x, and the coordinates of this point, I'll just call it x comma f of x. And now suppose I went further on the x-axis by a distance of h. Then the next point I would go to would be called x plus h, right? If I started with 1 and I went a distance of 3, it'd be 1 plus 3 and it would give me 4. So we're calling this x plus h. Well, what's the y value that goes along with this coordinate? Well, it's f of whatever x value you subbed in. So this would be f of x plus h. So the coordinates for this point, right, we would be calling x plus h comma f of x plus h, right? X comma y values. Now, when you're looking at the slope, right, of 2 points, we're using the average rate of change. And to find the average rate of change, what I'm really doing is I'm saying, okay, what's the slope between, you know, this point and this point? What's the slope of this line here that goes through both points? All right, and the slope of that line, you know, that kind of line that goes through 2 points on a curve, we call this a secant line. And the slope of that line you get from finding the slope between the 2 points that are on it, right? We know this point here, we know this point here. So that's the average rate of change, the same as the slope. Well, what's the average rate of change? Well, if I was following the formula from before, right? My slope, it's y2 minus y1. So f of x plus h, that's my y2 minus my y1 is f of x over here we're talking x2, which is x plus h, minus x1, it's just x, right? So I'm using these as my points, right? x1, y1, x2, y2. And I'm going to simplify this. So simplifying this, f of x plus h minus f of x, you can't manipulate, you can't get inside of these functions. You have to just write them as they are. F of x plus h minus f of x. Over here, x plus h minus x, well, x minus x cancels. This is all over h. So this is the average rate of change, right? It's the slope of that secant line between those 2 points. This is what we actually call the difference quotient, right? So this here is what we call the difference quotient. That slope that we just found. All right, so you know, we call it difference quotient. You may have seen it before. It's used fairly often, but I want to make sure that you've seen it. You don't have to develop how you got there, but you do have to memorize it. You do have to know what the difference quotient is if I talk about it. Now, once we have the difference quotient, what we do is we use it to find the slope of the tangent line. In other words, think about what the slope of the line that would go through 1 point. Right, so a tangent line is the line that goes through only 1 point on a curve. So suppose this point here kept moving downward lower and lower and lower. Then this, you know, secant line would change what it looks like. And what's really going to happen is this is getting closer and closer and closer together here. Right, so the point would be here, then it'd 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 be right on top of it. And as you get closer and closer, we're trying to find the slope of the line that goes through just that 1 point. Right, so this would be called the tangent line. So a tangent line is a line that only goes through 1 point on a curve. Secant line goes through 2 points. So I'm trying to find the slope of this tangent line. Well, it changes based off of this. Remember, this distance here was h, right? How do I get from here to here? I added h. So what I'm really saying is as h gets smaller and smaller and smaller, right? As h gets close to 0, that will give me the slope of the tangent line. And this is how we actually use limits to help us here. So to find the slope of the tangent line, we use, it's really the limit of the difference quotient. So it's the limit as h goes to 0, right? As h gets really, really small, that's going to give me, right, that point getting closer and closer and closer. So that limit as h goes to 0 gives me the slope of that line. This was the slope of the line. We're saying h is getting smaller and smaller and smaller. So it's the limit as h goes to 0 of f of x plus h minus f of x all over h. So that's how you find the slope of the tangent line. Now you can't just sub 0 in for h here, because then you would have something that's undefined, and actually you get indeterminate form, right? You would have a 0 in here, and then you get f of x minus f of x would be 0 over 0. So you can't just sub h equals 0 in. But if you take this limit, you can actually find the slope of the tangent line at any point that the function, any point that the limit exists. So we're going to use this a little bit later, but I want to make sure you see it. So this is going to come up in the next section, but it's important to understand the difference between the tangent line and the secant line and how we built that up. Later on we'll call this the derivative, but we're not quite there yet. So let's do an example here. So for f of x equals x cubed, find the difference quotient. So when I say find the difference quotient, I'm only asking you to do this part here, f of x plus h minus f of x all over h. I'm not saying to take the limit of it. That's something else. That's the slope of the tangent line. That's a derivative. So you should know that we're using f of x plus h minus f of x all over h. That's what it's asking us to find. And now you want to substitute in. Well, f of x plus h. If you remember from earlier, this means I already saw an x. You're going to sub in an x plus h. So f of x plus h, I'm just doing this as an aside. That's equal to x plus h quantity cubed. Make sure you're subbing the whole thing in for x. You're not just cubing the x and not the h. You're not just cubing the h and not the x. So the whole x plus h is a quantity cubed. And what you really have to do with that is, expand it. Now you can't just make it x cubed plus h cubed. That'd be incorrect. What it really means is multiply x plus h times itself 3 times, right? That's what something cubed really means. And if you've done this before, there are things that help you with, powers of binomials. It's called Pascal's triangle, but if you're not familiar with it, really you multiply it out. Like if I FOIL this, I end up with x squared plus 2xh plus h squared. I'm not going to show all the steps there. You should understand how to FOIL this, times x plus h, and then I'm really just going to distribute through. So if I distribute through this, right, each term here gets brought through. So x times x squared would be x to the 3rd power, x times 2xh would be plus 2x squared h, and x times h squared would be plus xh squared. And then I'm also going to bring h through. So h times x squared would be plus x squared h, and h times 2xh would be plus 2x h squared, and then h times h squared would be plus h cubed. So simplifying this, I end up with x cubed plus, this is 3x squared h, plus this is 3xh squared plus h cubed. So I'm just lining up those terms as I did it just to make it easier to add. But this is only replacing this first piece. That's what I'm showing here. That's why I did it on the side. So this is actually equal to, if I substitute in, All right, the f of x plus h is all of this. So it's x cubed plus 3x squared h plus 3xh squared plus h to the third power. All right, and then we have minus f of x. Well, that's minus f of x in this case is x cubed. Now, if there was more than one term here, you'd have to put this in parentheses and distribute the negative through it. And this is all over h. And now I want to simplify. Well, to simplify this, right, let's put this like that so it's on the side. To simplify this, you combine like terms. X cubed minus x cubed cancels out. None of the rest of this combines, so you end up with 3x squared h plus 3xh squared plus h to the third. And this is all over h. And now what we'll do is we'll factor from here. All right, we've talked about this earlier in the course. If you factor h out from the numerator, you end up with 3x squared plus 3xh plus h squared, and this is all over h. And then you're allowed to cancel these as long as h doesn't equal 0, right? So I can say these cancel, provided that h doesn't equal 0. Remember, we're approaching 0. We're not actually having it equal 0. So you end up with 3x squared plus 3xh plus h squared, provided that h doesn't equal 0. So, you know, that's how you would find the difference quotient. Now, if they ask you to find the limit, this is for next section, but it's something that's helpful to know. If I ask you to find the limit of the difference quotient, the derivative, limit as h approaches 0 of this, you still do everything the same, just you have limit as h approaches 0 in front. Once you get down here, limit as h approaches 0, you would actually evaluate that limit, which would end up giving you 3x squared. We'll talk about how that works in the next section.